I'm Sushma Nayak from Test Automation Studio, and today we'll be discussing about test. Like the topic for discussion is test harmony, design pattern, and anti-pattern unveiled. So here, like we'll be discussing, like we'll embark on a journey through the efforts of test design pattern and the pitfalls of anti-patterns in testing. Like why why we should quit anti-patterns and should like we'll be opting to more and more design patterns in our automation side. So yes, we'll be deep diving into this topic. So here I want to like I think everybody is aware about the knowledge etiquettes, but I want to like repeat it again. The first one is punctuality. So this is mandatory to join like 5 minutes prior to the session so that we can conclude on time. And the second one is feedback. So make sure to submit a constructive feedback for the session. The feedback form will be provided to you after the session. And the third is silent mode. Keep your mobile devices in the silent mode and feel free to move out of the session in case you need uh, to attend something urgent. And the last one is avoid disturbance. So avoid unwanted chit chat during the session, as the session is of a very limited time and there will be a lot of things to like cover during this time. So like quickly I'll be discussing what agenda topics we'll be taking forward today. So the first is introduction. We'll be talking more about like what is testing harmony, like, what are design patterns and what are anti patterns. So why we should not use anti patterns and why what are the importance of using design patterns. So this will be the introduction we'll be like looking into, and here only we'll be getting a clear picture about what the topic is all about. Now the second one is understanding design patterns. So here we'll discuss what are design patterns and the common design patterns in testing, like few of the commonly used design patterns which are there in the market and which are commonly used while designing a framework, irrespective of any tools and technologies or any languages. So we'll be discussing more about that. Then is implementing design pattern in testing. So here we'll be discussing about a few of the design patterns which are commonly used, like page object model, which I think everybody knows about this term page object model. So we'll be detailing it out what is page object model. Then we have factory pattern, and we have few more there, but these two are the important hot topic of discussion for design patterns. Now the next one will be unveiling anti patterns. Like we'll understand the detail what is anti pattern, as I guess many of them might not have heard about the term anti pattern, but yes, everybody is like maybe using somehow in their while they are coding. But yes, they'll be knowing what is anti pattern and then common anti patterns in testing, and what are the risk and the challenges posed by anti patterns in testing projects. So here we'll be dealing all the we'll be getting a detailed picture of anti-patterns and why it should not be used. So now the fifth point is mitigating anti-pattern with best practices. So once we understood what is anti-patterns, now the next thing which will be coming in our mind is like how to like mitigate this anti-patterns from our code. So we'll discuss more about this in this slide. So we'll discuss identifying and addressing anti-patterns, how we'll be knowing how to identify those patterns, and then promoting good testing practices. This is very important. I think every uh, whenever somebody new is coming to any coding team, so they might be like the the people might share them a good practices, list of few good practices which they follow, or we can discuss more about the like promotion of good testing practices here also. Now the last one is importance of code review, refactoring and collaboration. It's not like every time we'll write our code and we'll directly merge and it will go ahead. No, it's not like a best practices to be used. It's like every time whenever we are writing code or whenever we are scripting, it's always important to have code reviews, refactoring and then collaboration, as this will help us in unveiling anti patterns. Finally, conclusion, and then yes, if you have any questions, so we can take it forward. uh, Now the first is introduction. Now here now as we all know that testing is an integral part of our software development life cycle, and it ensures the quality of the product, but also shapes the efficiency and the reliability of the process. So this means that here, like, we'll explore how carefully application of design patterns can streamline our testing efforts, and while uncovering the dangers or the anti patterns that threatens to disrupt our harmony. So as already discussed in the previous slide, that throughout this session we'll delve into the fundamentals of design patterns. Like mostly we'll focus on design patterns and the anti patterns. So examine their roles in like how we are maintaining and scaling our test suits, and by the end I think we'll hope to equip everybody with the knowledge and insights needed to navigate the testing landscape. Yes, so let's start with the topic testing harmony, design patterns, and anti patterns. So, moving ahead, this is understanding design patterns. So here we'll understand what are design patterns. Now, if you read the definition which is provided in the slide, it says that design patterns are essential blueprints that guide the structure and organization of our software system. Now, in context testing, design pattern serves as proven solution to common problem encountered during the test automation. So here, like in this section, we'll delve into the fundamental of design patterns, like exploring their significance in testing and their role in promoting efficiency and maintainable test suite. Also, we'll examine various design patterns commonly used, such as like page object model, factory pattern, singleton pattern. Uh, there are many terms here. So, we'll like deep dive into this, like how the design patterns are important in our day-to-day life while we are coding. So if like many of us might not know what are design patterns, so I like to give one example. Like if you talk about like it is a recipe of solving common problems in software development. Just like if you're cooking a dish, a design pattern offers a structured approach to solving specific problem. Um, what we can say that by using design patterns, developers can create software that are more modular, flexible, and easier to understand and maintain. So whenever we if I give you an example, like if you're build like if an architect is building a house, so it's not like every time they'll be like coming up and dealing everything from the scratch. So what they can do is that if they have to build a house on a daily basis, so what they can do is like they can prepare uh, skeleton or the structures in the prior, and they can use that as a reference, and then they can build the house. So it's like you need to decide the layout of the room, and instead of starting from scratch every time, you might start a standard floor plan. So the plan can be there and you can just implement that plan. So similarly, in the software development, design pattern provides standardized solution to common problems, and making it easier for our developers to build software that meets quality standards and are easy to maintain. So few of the examples are there, will be which will be detailing it out in the next slide. So then only you'll be able to understand like what are design patterns. So it's almost the same. We are creating some skeleton, or the some of the structures are already there in the market with some names. And what happens whenever we are designing our framework, we can just take out any of those patterns and we can implement in our framework. Why we are implementing it? Because to make it more reliable and to make it more flexible, as reusability and everything can be done. So uh, now if you move ahead, so common design patterns in testing are uh, like as we already discussed in the previous slide, what are design patterns. So these are few of the commonly uh, design patterns in testing, and which we'll be covering out. The first one is page object model. This is like very hyped design pattern. I think each and every automation tester might be aware about this term. So what is this? So we can also say it, page object model can be also, we say by name POM, and it is a pattern used primarily in UI testing to represent web pages as an objects. So here everything is treated as an object. So what happens in each page, we encapsulate within a separate class with methods representing interaction and assertions on those elements. So what we do is that if we talk about a login page, so we have a page called login. So its methods and its like the locators which we are keeping in one page, and then we are, whenever we have to use that somewhere, so we'll be calling it out and then we'll be using it. So what is the benefit of this? Now it encourage code reusability. Like every time, like there may be n number of test cases where we n number of test cases already written, and n number of times we have to log in. So it's not mandatory to write login every time. What we will be doing, we'll be calling that login function every time from that page, and then we'll be just using it. So it makes it reusable. The second one is reduce code duplication. Obviously now we are reusing that the function, so it is reducing code duplication. Like we are not every time writing the same piece of code on the n number of test cases. And enhances maintainability by centralizing page specific logic. And the use cases, like it is very much suitable for UI test automation testing framework like Selenium, where the test interacts with the web elements on different pages. Now next one is the factory pattern. So what is factory pattern? It defines an interface for creating objects, but allows subclasses to alter the type of objects that will be created. And it provides a way to delegate the logic into their subclasses. So it has class, and it has it has its subclasses with it. Now the benefits are it supports dynamic object creation and promotes loose coupling between test code and concrete implementation. So where we can use factory method pattern, it is suitable for scenarios where different implementation of component needs to be created based on specific condition or configuration. So from so it can be used on those scenarios where the code are very complex. So there we can use factory pattern. The next one is uh, the builder's pattern. Now what is builder's pattern? Builder's pattern separates the construction of complex objects and its representation. So if the code is very complex, so it will be just making it a little, like it will be filtering and making it little simpler. And it allows for creation of objects step by step with a flexible and customized and then it will customize their properties. So what is the benefit of it? It enhances the test data management and improves test maintainability by decoupling the objects. And use cases is that it is particularly useful for creating test data objects and configuring test fixtures or the test context. So yeah, and we have singleton pattern also. And yeah, so these are like commonly designed patterns in testing, and they are like majorly whenever we are designing a framework, as I've already said, we should be always thinking about any of the pattern, and should implement one of the pattern to our framework, depending upon what the pattern is doing. Uh, so implementing design patterns in testing, we'll be detailing it out what is page object model, and just giving a little brief about this these patterns. So first one is page object model, and here it's already in the previous slide we have discussed a little bit about this. So we have already discussed that this is useful for UI test automation, and particularly for web applications. So whenever we are writing a test script for UI, so we'll be always keeping in mind about page object model. And it aims to enhance the maintainability, readability, and usability of test code by abstraction and UI components of web pages in separate classes and objects. So what is the purpose of using it? Obviously, it does like it creates an abstraction between the test automation code and the UI elements. So, and it also encapsulates the functionality and the interaction of individual web pages within a separate page object classes. So I've already given you example of the login in the previous slide. So yes, this is the purpose. And there are few of the key components there. We have page objects. So the each web pages like the login, then we'll be having the landing page or something like that. So these pages are known as the page objects, and we'll be creating page object classes which encapsulates the elements and the interaction of that pages. The second key component can be UI element. Now UI element can be like button, text field, drop down, anything whichever locator we'll be looking into. So those will be complementing as UI elements. Then comes the methods. So the methods within the page object class define actions or the operation can be performed on the UI elements, like clicking a button, entering text field into the field, or doing a simple login thing. So these things can be considered in methods. Now the fourth one is assertion. Here in assertion, the page object uh, methods may also include assertions to verify the state or properties of UI elements, like verifying text, visibility, etc. So whatever thing the test case is saying, like if we say login, so we need to check whether we have logged in or not. So these are the things we say it as assertions. Now, what is the benefit? Benefit is code reusability. Already discussed. Like we'll be reusing this the one piece of code every time. Maintainability. Um, Obviously, if we are using like if there is some changes done, so we do not have to make the changes every time every piece of code. Only we'll be doing on the main page object, and from there only we are calling, so it will be the changes will be done at a place. Now readability. So test script becomes more readable and intuitive because they interact with the page objects rather than directly manipulating in the UI element. And then reduce duplication, as we are reusing, so duplication is already reduced. Now separation of concerns, like POM encourages a separation of concern between the test and the logic and the UI detail. So so this is what the page object is all about. In like the page object model is a is a powerful design pattern for structuring UI test automation code in scalable, maintainable, and in a reusable manner. So so if you see in this example, this is a page class where the elements, whatever we were saying, the page objects will be here, and then these are the test cases where we'll be calling it out. So for if we include both of this, becomes page object model. Now the second one is factory pattern. So the factory pattern is a creational design pattern that provides an interface for creating objects in a superclass, but allows subclasses to alter the type of objects that will be created. So if you see in this example, there's a method called deliver. This method may be having all the things that is required to be covered under deliver, but this has to be done through two modes of transport, which is truck and ship. So it's not like only we'll be calling this deliver function will making it will this truck and this ship will be using what these transportation mode will what they'll be doing, they'll be modifying it according to their use. They'll be using this function, but they'll be modifying a bit according to their use, like this delivery by land in box. So it will be modifying, the functionality is there, but it will be modifying according to its use, that it will be a land box and it will deliver by C. So it will be calling the this function, and then it will be modifying according to its use, that it will be like transporting will be done through C. So this is what we call a factory pattern. Now the purpose is that the factory patterns aims to delegate the responsibility of object uh, specified factory classes, and it abstracts the process of object creation. It allows client to use common interface to create objects without being aware of their concrete implementations. So the concrete implementation can be done somewhere else, and just that can be used by the clients. Like these are the clients which are using this function, but they do not have to go very much deep inside this function, like what everything is there in the function. They are just using that function. Now how we are implementing it, like we'll be define product interface first, and first like create an interface or an abstract class to define the common method that all product must implement. So here we'll be creating an interface, and then the common methods will be putting there. Then implementing concrete product, like the like here what we'll do, a concrete class will be there that implement the product interface and representing variation or type of product. Then create factory interface. Here we'll define interface or the abstract class that declares the factory method, and then implement concrete factory. So here we'll develop a concrete factory class that override the factory method. Now the use cases are dynamic object creation. So when the type of the object to be created is determined on the basis of runtime based and creation condition, or the configuration. And the plugin system, like when a system needs to support dynamic loading or of plugins or extension at runtime. So here we can use our factory pattern. And what are the benefits? That the benefits are encapsulation. So it encapsulates it encapsulates object creation logic and promoting modular and maintainable code. Now, the second one is flexibility. Obviously, it makes it more flexible without modifying the client code they can use. And the third one is testability. So, it can be easily testable. So, yes, this is the like factory pattern is a powerful tool for decoupling objects creation logic from client code, promoting flexible and like maintaining maintainability and testability in the software design. Now, moving ahead, now here we'll be defining what is unveiling anti-pattern. So here we'll be talking more about like introduction of anti-pattern. What is anti-pattern? Its definition, and then what are the common anti-patterns in testing? There are few names already given to these anti-patterns, so we'll be discussing about them. And then finally, what are the risks and the challenges that we have to face? So yes, what is the definition of anti-pattern? So here in the slide, if you can see, the anti-pattern is a software testing refers to common practices or behavior that are counterproductive or ineffective in achieving the desired outcome of testing activities. So now, what is the significance of anti-pattern in testing is that identify problematic practices. Uh, this means that this anti-pattern help tested and team recognize common mistake or the practices which has been like they have been doing, and by identifying these patterns, team can proactively address and make their strategies by defining more design patterns or implementing more design patterns to their testing skills. So, so here, like the overall is that understanding and addressing anti-pattern in software testing is like really essential for improving the quality and efficiency of testing efforts. And by like proactively identifying these patterns, a team can optimize their testing process, and then they can deliver better software products to the customer. So yes, it's very important to identify the anti patterns which have been there. uh, Now the common anti pattern, we'll be talking about the first, the very famous one is the god object anti-pattern. So we'll be discussing a little bit about uh, this here, and in the later slide also we have little bit to discuss about this. So as already discussed, that what is the anti-pattern. So anti-pattern is like a test class which becomes very complex and bloated, like as attempting to handle too many responsibilities within a single entity. Here what happens, like within a single entity, we are writing we have made a class and we are writing each and everything inside that. So in a flat structure, so there is no oops used, nothing used. We are just writing all the methods in a particular class. So what makes it more complex, and then it makes it more bloated. So this is the god object typical accumulates numerous method assertions, test scenarios, and like it all obviously, if you are writing everything inside it, it will make it more difficult to understand, maintain, and extend. So whenever somebody is learning to write code, they obviously they'll be starting with this phase. But yes, this is not like said to be a good practices, but yes, whenever one is starting, they can start with this, but they should move on to some of the design patterns. Now, what are the sign of good god object anti-pattern? Is that large test cases, like high number of test methods are there and exceeding the reasonable limit. So this is one of the sign. Then excessive dependencies. Now the tests are heavy and rely on external dependencies or interact with multiple components. So this makes it more increase in like more complex. Then we have lack of cohesion. Test classes that lack a clear focus, mixing unrelated test scenarios and responsibilities. Now we have difficult to maintain. Here, what happens? The test code that is challenging to modify, extend, or debug due to size of the complexity. Obviously, now the size is too big and the code is already become complex, so it is very difficult to maintain. So, what are the impacts of anti-pattern? So, it decreases the readability, or so the testers cannot understand the intent and the purpose of the test scenarios, as everything is written into a single in a single class. So hence it decreases the readability. Then increase fragility. Now changes our underlying system, and like this may cause, if we are doing some changes there, it may cause unexpected failures in multiple scenarios, like as we hear, tight coupling is done and lack of isolation. So it may be like the case that if somebody is, something is is being changed here, may impact to some other test scenarios also. Now reduce test effectiveness, as obviously the size and the test case have made it more complex and may lead to gaps in the test coverage, and it becomes challenging to verify all possible scenarios. So it is, hence it is reduced in test effectiveness. And yeah, the longer test execution time it will be taking, because of the wide range of functionality and scenarios, everything is there. So obviously the slower the feedback cycle, the cycle will be slower. Now, what are the risks and the challenges posed by anti-patterns in testing projects? So obviously, the first one is decreased test code quality. Already discussed, like the code is very vast, and it's in a flat structure. So obviously, decrease in test code. Now, increase maintenance overhead, as we are not able to understand the code, so it will be obviously making the maintainability will be a overhead. Reduce test reliability, and then difficult in scaling the test. So uh, it's all due to like writing everything in at a place. So here what happens, like in scaling, like anti-pattern inhibit the scalability of test suite, and it will be making a challenging to expand the test coverage or accommodation changes in the system. uh, the last one is negative impact on the team morale. So it's always like writing and then making changes, and then the impacts will be in maybe on many of the other classes also. So what will happen, this will obviously like demoralizing the team members and leading to like frustration, dissatisfaction, burnouts, etc. So addressing these risk and challenges requires proactive identification and mitigation of anti-patterns in testing projects. So hence what we can say is, hence whenever designing a project or a framework, anti-pattern should be taken out in the starting. Which means that a culture of clean coding, continuous improvement, and collaboration testing team can be done. So how we can overcome, we'll be discussing in the next slide. uh, this is mitigating anti-pattern with best practices. So here we'll be discussing more about the anti-patterns, like how we will be able to take out all the anti patterns with our best practices. And whenever somebody is coming to your team, and you'll be able to explain them what how to adapt the best practices. Now first one is code review and peer collaboration. So yes, regular code review should be there. It's not like you are writing a code and then you are directly merging it out if there is no reviewer with you, but you can do a peer collaboration to get more and more insight about um, the situation. The second is static analytical tool. Some tools are there um, which can be which automatically identifies anti patterns and the code smells in the test, in your test code. So yes, so this can be also done, and we can integrate it with our CI pipeline so that we can catch all the smells and everything prior only. Now the third one is refactoring the code cleanup. uh, s- there should be a session to schedules. Regular session should be there to refactoring session to clean up the code and addressing identified anti patterns. Now, the next one is test automation principles. Design test scenarios with a clear focus on specific functionalities or use cases for promotion. The next one is modularization and on compensation. Here what happens, like test code to reusable components and libraries should be like we should promote them and should use them. Then is test data management. We should implement test data management strategies to avoid anti patterns. Like whenever we can give one example, like data driven testing approach can be used here. And then continuous learning and improvement, we should create sessions and we should foster a culture of continuous learning and improvement within the testing team. Then we have documentation and knowledge sharing. This should be always implemented whenever we have some sprints or something is going on. We can, after sprint is done, these things can be taken care of, like and document identified anti patterns so that they cannot be repeated again. And then share knowledge whatever we have gained during the development. Mm. So here we have a few of the anti patterns which we have which we have discussed earlier. Like god object we have already discussed, and few of them are like spaghetti code. Here what happens, like highly interconnected and hard to maintain code is there, and because of that, like lack of separation and concern often leads to messy code, and it is like very difficult to understand and maintain. So these things should not be there. God object we have already discussed. Then we have premature optimization. Here what happened, like optimize code before, we should optimize the code before identifying and addressing performance bottlenecks in the anti pattern. In case, what happens, like increase the complexity and reduce the code readability. So yes, so this should not be there. Now copy paste programming is what we call anti reusing the components. So repeatedly copy pasting the same block of code every time will make it more code duplication will be there. Then the last one is magic numbers. What is magic numbers? Like using hard coded numeric values directly in the code. So hard coding should not be done, and it should be outside the code. So whenever there is, if we have to use for n number of places, we n number of, like the values and number of times we have to use, so we can use, so we can consider it through a variable and define the numbers in that variable, and then we can use it. Now identifying and addressing anti patterns, so already discussed, like we should use some static analyzing tools, and then we should conduct code review. So these two are very important things. So utilize like static code analyzing tools to automatically detect the potential of anti patterns in the test code. Now we should configure this tools to like remove those anti patterns such as the hard coding things. So we can integrate in the CI pipeline also to catch them in the early development processes, as we have already discussed. And the second one is code reviews. Already discussed that what are the advantage of having the code reviews. So yes, regularly review test code as a part of development should be there, and look for signs of complexity, redundancy, and lack of maintainability in the test code. So because of this reason, like code review should be there. Like we should encourage our team members to provide feedback and suggestion for improvement during the code reviews. So whenever there is a code review meeting or the peer collaboration is there, uh, like continuous feedback should be provided. Now promoting good testing practices. Now these are few of the like testing practices we should follow. The first one is test driven development, TDD. Here what happens, like write the test before writing the code. So what happens, like this is a very plus point. It will ensure that the code is developed to meet the requirement. So this will help you to, it will be like you'll be already clear with you'll be having a clear picture what the test this code will be, and you'll be not again erasing and rewriting the code. It helps in clarifying requirements and design before implementation, and this leads to a better design code. Now the second one is automate testing. here what happens, like we should promote automate as much as testing process as possible to save our time and effort, and CI/CD pipeline can be used to automate the testing process. The next one is test in isolation. So write tests that are independent of each other to isolate issues and make debugging easier. Then we have comprehensive test coverage. We should aim for comprehensive test coverage across different level of testing, like unit testing, integration testing, and end-to-end testing. And then refactoring and regression testing, regular refactor code to improve design readability and maintainability, already discussed. And then we have continuous feedback. So we should incorporate feedback for testing into development process to improve the quality of the software. And we have few more like continuous learning and improvement. So these processes we should follow among, as we say, like these are like good testing practices, and team can ensure quality, reliability, and maintainability of their software products. Now moving to the next slide. Now, what are the importance of code reviews, refactoring and collaboration, addressing anti-patterns? So already discussed what is code review. So we should do a code review. Then we should do a refactoring of code should be done. It's not like once we have done, it should not be done again. Yes, we should define some meeting times like within 2 weeks or within 3 weeks. Every 2 weeks we should have, so that we can take it out, more and more refactoring can be done. And then we have a collaboration like knowledge sharing, building a culture of quality. So these can be done. And then finally we have our conclusion slide. So here we'll be concluding what the topic was all about. So yes, testing harmony, design pattern, and anti-pattern unveiled emphasize in the critical role of design patterns and the necessary, like the necessity of addressing anti-patterns. So understanding design patterns, like what are the design patterns which are there, and we can implement to lead to improve test coverage and effectiveness. Then identifying the anti patterns, if there are some anti patterns or the pitfalls or the bad practices there, it should be taken care of and it should be omitted in the starting of the phase. Then promoting test harmony. So more and more leveraging design patterns for effective test design, and mitigating anti patterns should be there. So this balance are crucial for achieving comprehensive test coverage. And then we have a role of collaboration. So collaboration means like developers, testers, and other stakeholders should collaborate with each other to promote a testing harmony. And this is also very important to have a role of collaboration, like open communication and shared ownership of testing responsibilities. These are the key for these testing harmony. And then the final one is the continuous improvement. So once everything is been done, continuous improvement should also be taken care. Like testing harmony is not one time doing, it should be continuous improvement. So once we figure it out, and we should incorporate in our like the team must regularly review and refine their testing practices and incorporate like feedback, and then embracing new technologies, adapting or involving new requirements. If somebody has learned something, they can share their knowledge with the other team members. So these things can be done. So because of these, the continuous improvement can be done not only in the project, but with the teams, like the team members also. So this will all, if this is being done, all this means that testing harmony is being maintained among everybody. So yeah so this was all about the topic. And if you it's we all have 1 minute of time. If you have anything to ask or any question, we can take it now.
Guys, please use this opportunity as Sushma will also be nominating two of you as the spotlight. So it's already 4:15, but we can wait for one more minute. Anybody has any questions? Anybody? Do we have any questions? All right, then, Sushma, I think we are good to close the session now.
Okay, okay then. Thank you so much,
Right. So
everybody.
thank you so much, Sushma, for the wonderful session. And thank you so very much, everyone, for attending the session. See you all soon.